Welcome back to the Deep Dive. This is part of the Data Zen AI Podcast, and we're put together by the Data Zen community.
That's right. And our goal here is really to help you listen and learn about AI, wherever you are. We're on all the main podcast platforms.
So if you're listening, I bet you've already started using AI tools, right? Things like ChatGPT, Claude, maybe Gemini, in your day-to-day work.
Absolutely. They're becoming pretty common.
But, and maybe this sounds familiar, you get that inconsistency. Sometimes the answer is just brilliant, saves you tons of time. Other times it's just, generic, flat. Sometimes just plain wrong. It's frustrating.
Yeah, that inconsistency, that's the hurdle, isn't it? Especially for IT pros, trying to really weave these tools into their actual workflows, not just playing around.
Exactly.
So that's why we're doing this deep dive series, helping folks learn about applying AI seriously from anywhere. And today, we're tackling that core skill, the one that smooths out those hit or miss results. We're talking about prompt engineering.
Right. And if you're in IT, it could be a developer trying to map out complex architecture, or maybe a PM needing risk reports synthesized.
Or an analyst needing precise data points, a tester generating scenarios.
Yeah, anyone, really. Learning how to talk to the AI model, that's probably the highest leverage skill you can pick up right now.
It really is. It turns that general purpose LLM into a specialist assistant, customized just for what you need.
And we want to show you this isn't some deep theoretical machine learning thing.
No, not at all. It's more like applied communication. Think of it that way. The models are incredibly capable, but they need clear instructions, a good blueprint.
Okay, let's unpack this. So let's start by getting everyone on the same page. For our audience, developers, analysts, when we say prompt engineering, what are we really talking about? What's the mechanism here?
Okay, good question. Prompt engineering, fundamentally, I call it the discipline maybe. It's both art and science. It's about carefully crafting those input instructions for large language models, the LLMs, so you reliably get back outputs that are accurate, relevant, and crucially useful right away.
And the focus is on the input because of how these models work.
Exactly. The core function of an LLM is basically predicting the next word, or rather the next token.
Tokens, those are like the pieces of words, punctuation, the things the model actually processes, right?
Precisely, little fragments of text. So when you give it a vague prompt, like write a summary.
Yeah, done that.
We all have. The model sees this huge space of possible next tokens that are statistically probable. Usually leads to something pretty generic, low value,
Okay.
good prompting. It's the process of strategically narrowing down that probability space. You give it structure, context, clear instructions. So much so that the model's prediction path gets focused onto one very specific, useful output.
So it's not just telling it what I want, it's more like reducing its options so it doesn't have to guess so much, minimizing the cognitive load for the AI.
That's a great way to put it, minimizing cognitive load.
Yeah.
Because, those early attempts often fail when people treat it like a fancy search engine.
Like asking for an article about productivity tips.
Right. And you get back the most common, bland advice ever.
Yeah.
The history of prompt engineering is really this quick evolution away from those vague commands towards, engineered communication.
Moving from just asking for something to defining how it should get there, the criteria, the constraints.
Exactly. Defining the process the model needs to follow.
And for technical folks, that precision is gold. It's the difference between asking for a Python function and getting some basic snippet.
Maybe with bugs or bad error handling.
Versus getting a properly commented, maybe even tested function that follows best practices for, say, Python 3.9.
That's the key shift. You're engineering the input to basically guarantee quality control over the output.
Okay, so beyond just getting better answers sometimes, why is this a critical skill? Why should every professional, especially in IT, be focusing on this right now?
Well, the biggest reason is probably quality control and reliability. Simple as that. In IT, bad output isn't just annoying, it's risky.
Right. It could mean introducing bugs into code.
Or basing decisions on inaccurate data analysis, or even facing compliance issues. And that gap, the one between a so-so response and a really exceptional one, it almost always traces back to the prompt, not usually the model itself.
And this connects directly to that big fear. Everyone has hallucinations, right?
Absolutely. Hallucinations when AI just confidently makes stuff up, that's the single biggest barrier to trusting these models for serious professional work.
Yeah, that's scary.
But the good news is Prompt engineering is your main defense. There's research showing that if you provide solid context, or you force the model to think step by step, or demand, it justifies its answers. It actively reduces the chance of fabrication. You're essentially grounding the model, giving it less room to invent things.
So the prompt becomes less of a simple request and more like scaffolding, something to keep the model on track and verifiable.
Exactly. It's scaffolding for reliable output. And importantly for everyone listening, these principles we're discussing, they work across the board.
Model agnostic, you mean?
Totally. Whether you're using Claude for its long context, or maybe GPT-4 for its structure, or Gemini for research, mastering these core techniques helps everywhere.
It's like learning clean coding practices benefits you no matter the specific language or framework.
Perfect analogy. And for someone learning this, it's really a shortcut. You get past that frustrating trial and error stage much faster.
And start getting the knowledge you need, how you need it, right away. Better ROI on using these tools.
Precisely. Maximize that return immediately.
Okay, let's get practical. Let's talk about techniques that give you those quick wins, the things that make an immediate difference, starting with the absolute foundation, clear and specific instructions.
Yes. Technique number 1, be explicit, be unambiguous. Sounds basic, right?
Seems obvious, but
it's where most prompts stumble initially. You need to tell the model exactly what the task is, what you expect the output to look like, and any absolute rules or constraints.
why does just being specific work so well, though, at that sort of mechanical token level? Why can't the AI just figure out, I want a good response?
Because figuring it out involves probability, which means ambiguity and risk for the model. Specificity immediately cuts down that massive space of possible next tokens we talked about.
Okay.
Instead of the AI having to search its entire training data for something vaguely related, a tight prompt guides it directly towards a particular answer structure. It limits the scope. It's like defining the execution environment for your request.
Right. Let's make that concrete with an example. Weak prompt. Tell me about climate change.
Yeah, that's asking for, what, a 10,000-page textbook condensed? Not very useful.
Okay, so the strong version.
Strong prompt.
Okay.
Explain the 3 main causes of climate change and their environmental impacts. For each cause, provide one specific quantified example. Structure the output as a markdown table.
Ah, see, the table constraint there is brilliant. It dictates how many causes, 3, the focus, causes, impacts, quantified examples, and crucially, the format, markdown table. Means I can just copy and paste that straight into a doc or presentation.
Huge efficiency gain. And a quick practical tip here, especially for our IT audience. Use simple, direct language.
Avoid jargon unless it's necessary for the role.
Exactly. Avoid overly complex sentences or, flowery vocabulary. Think of your prompt as an instruction set for a machine, not an essay. Direct phrasing reduces the chance of the LLM getting confused. Okay, technique 2, context. Context is like the gravity for your prompt. It holds everything together. The principle is simple. Ground the AI's response in facts, background details, or the specific situation.
Don't make it guess.
Precisely. Don't force it to infer missing information. This is absolutely vital for things like summarization or question answering based on specific documents.
And for a developer or an analyst, this is where you bring in your own data, right? If I need a summary of my Q1 sales report, I have to give it the report.
That's the core idea. Providing that context, maybe by pasting text directly or using more advanced systems like RIG, retrieval augmented generation, dramatically improves relevance and, crucially, accuracy.
That's so.
Because the model then treats that provided context as its primary source of truth for the task. It's much less likely to pull in outside information that might be outdated, irrelevant, or just plain made up.
Okay, let's take that summarization example again. Weak prompt. Summarize this report.
Yeah, you'll probably just get a generic abstract, not very targeted.
So the strong contextual version, tailored for, say, an IT leader.
Right. Strong prompt. I have a chief technology officer preparing a risk assessment for the board. Summarize this security vulnerability report, and then you provide the report text, maybe in triple quotes, focusing only on vulnerabilities rated critical or high. Explain the proposed mitigation strategies and specifically highlight any potential regulatory compliance breaches identified, like GDPR or CCPA.
Wow, okay, so the AI now gets the whole picture. Who I am, CTO, who it's for, the board, so needs strategic language, the specific focus, critical high vulnerabilities, and even a compliance filter.
Exactly. It's tailoring the summary not just based on the data in the report, but based on the professional context and the task you've defined. You're essentially asking it to adopt the viewpoint, the risk perspective, of a CTO.
So the tone, the vocabulary, the level of detail, it all shifts to match that role. Much more valuable than a generic summary.
Far more valuable. It becomes a tool for that specific executive briefing.
Which leads us nicely into technique 3, role or persona prompting. This is one of my favorites for quick, noticeable improvements.
This is where you tell the AI who it should be.
Precisely. You assign it a specific role or persona, like you are a senior database architect, or you are a junior compliance analyst, or you are a technical writer documenting APIs.
And that constraint really works.
It works incredibly well because it forces the model to constrain its style, its vocabulary, and even its knowledge domain to match that persona. I find it almost instantly makes the output feel more professional or more appropriate because it starts using the right kind of jargon and focusing on the right things for that role.
It does. What's happening underneath is that the prompt activates the parts of the model's training data most relevant to that specific role's expertise and communication style. So you get much more consistent, contextually appropriate language.
Okay, can you give us some more in-depth examples, maybe more technical ones than the usual? Explain this like a high school teacher scenario.
Yeah. Let's think about debugging code. Instead of just pasting code and saying, fix this.
Which might give you anything.
Right. You could say, you are a senior DevOps engineer specializing in Java performance optimization. Analyze the following code snippet, then paste the code, and identify 3 potential thread safety issues or memory leaks. Explain your findings using terminology appropriate for a peer review conducted by other senior engineers.
Okay, that's specific. It forces the AI to look beyond basic syntax errors and consider much more advanced performance-related issues using the right professional language.
Exactly. It leverages the deep, specialized knowledge embedded in the model's training. Or another one, maybe for regulatory stuff.
Good one.
You are a junior compliance analyst at a major financial institution. Based on the provided client communication transcript, paste transcript, classify the interaction's risk level as high, medium, or low. Justify your classification solely using direct excerpts or principles from the Dodd-Frank Act guidelines.
So that ensures the output isn't just a guess based on keywords, but a constrained analysis grounded in specific legal or regulatory frameworks. And it adopts that careful, precise tone of a compliance officer.
Precisely. Role-based prompting primes the AI not just to act like the expert, but in a way to think like them, focusing on the relevant knowledge and communication style. Huge for professional quality output.
Okay, so we've covered making the AI accurate and context-aware, but that's only half the battle, right? In a professional setting, the output needs to be immediately usable. We can't waste time reformatting paragraphs of text.
Absolutely. This is where we need to impose structure. So technique 4 is specify the output format using constraints.
This means telling it exactly how you want the answer laid out.
Exactly. Define the structure precisely. Do you need a numbered list, a JSON object, an XML file, a markdown table? Do you have length limits for certain sections? Do you need it to fill in a specific template?
This sounds critical for any kind of automation, doesn't it? If you're piping the AI's output into another script or system.
It's essential. That system needs a predictable, consistent data structure. Defining the output format makes the AI's response controllable, predictable, and often machine-readable.
And it probably helps with quality, too, by forcing conciseness.
It does. It limits verbosity. If you demand a response formatted as a JSON object, the AI has to strip away all the conversational fluff and just focus on the key value pairs you asked for. It inherently increases the signal-to-noise ratio.
Can we push this? Give us an example of a prompt demanding a really complex, maybe nested structure.
Okay, let's say you're analyzing user feedback. You could prompt, you're analyzing raw user feedback comments. Process the following 10 comments. Then provide them. Classify each comment into one of 3 categories: performance, UI/UX, or feature request. Provide the output as a single JSON object. The top-level key must be an array named feedback analysis. Each object within this array must contain keys for ID, use the comment number, category, and summary, which must be a maximum of 20 words. Ensure the entire output strictly validates against standard JSON schema.
Wow. Okay, so by demanding strict JSON schema adherence, you're not just asking for formatting, you're basically enforcing data quality rules for whatever process comes next.
That's the goal. And a crucial tool to make this work, especially with complex prompts, is using delimiters.
Meaning?
When you're mixing instructions, the context, like those user comments, and the required output format description all in one prompt, it can get messy for the AI.
Right. It might confuse instructions with the data it's supposed to process.
Exactly. So use clear markers to separate sections. Triple backticks are very common. You could also use XML-like tags like instructions and instructions, context and context, or even just simple headers with lines like instructions. This helps the model clearly distinguish between what you're telling it to do and the data it needs to work on. Prevents a lot of common errors. All right, technique 5 gets into something really powerful, few-shot prompting. This is basically the show, don't just tell approach.
So instead of describing what I want, I give it examples.
Exactly. The principle is to include one or maybe a few complete examples of the input-output pair you're looking for, right there in the prompt itself. You show it the pattern, the style, the specific logic you want it to follow.
Why is showing often better than telling, especially for tricky things like matching a specific writing style or doing complex classifications?
Because LLMs are fundamentally pattern-matching machines. If you tell an AI, write this report professionally, it has to guess what you mean by professionally in your specific context.
Which could mean anything.
Right. But if you show it, say, 2 examples. Here's a previous technical spec, and here's the kind of executive summary we generated from it. The model learns the specific rhythm, the vocabulary, the level of detail, the length constraints that your organization considers professional for that task.
So this lets you go beyond simple instructions and get into really specialized stuff, like imitating a specific brand voice or doing custom data extraction where the rules are subtle.
Precisely. Imagine you need the AI to classify customer support tickets into very specific, maybe non-obvious categories, instead of trying to write out 20 complex rules.
Which would be hard and probably incomplete.
You just provide 3 clear examples. Input ticket A, output category X. Input ticket B, output category Y. Input ticket C, output category Z. The model often grasps those subtle distinctions much better from examples than from abstract rules.
Okay, but hold on. If I'm a project manager trying to generate, say, 50 status updates using a specific template, crafting a few-shot prompt with examples for every single one sounds really inefficient. It would make the prompts huge.
That's a very important practical point. There's a trade-off. Few-shot examples definitely work, but they consume prompt space. They use up valuable tokens.
Which means more cost and slower responses, right?
Exactly. Especially if you're dealing with models that have large context windows you want to utilize fully. So the scalable approach isn't necessarily to use few-shot for every single request. It's to use it strategically.
How so?
Use few-shot prompting primarily to teach the model the difficult, non-standard, or critical pattern you need it to learn. Maybe it's a proprietary citation format or a really complex nested data structure it needs to extract, or that specific brand voice.
Okay.
Nail down that specific tricky part with a few-shot example. Then you might chain that into a simpler, more token-efficient prompt for the bulk processing, relying on clear instructions, technique 1, now that the model understands the core pattern.
I see. So use few-shot examples for the heavy lifting on the unique rules, but then rely on simpler instructions for the repetitive execution part. That's clever token management.
Exactly. It balances effectiveness with efficiency.
Okay, we've covered getting the structure right, providing context. Now let's really level up. Let's talk about techniques that force the AI to be more reliable, more accountable, and even handle complex logic.
This is where it gets really interesting, I think.
Agreed. Because now we're talking about making the AI not just respond, but reason.
Starting with technique 6, chain of thought prompting, or COTI.
Yes, chain of thought. This has been a huge breakthrough in LLM performance, especially for complex tasks. The core idea is surprisingly simple, though.
Which is?
You instruct the model to essentially show its work. Ask it to generate the intermediate steps, the logical pathway, the step-by-step reasoning it used, before it gives you the final answer.
And just asking it to think out loud like that makes the final answer better. Why?
It seems to. By forcing the model to explicitly lay out its reasoning path, you're essentially breaking down one complex, potentially error-prone leap into a sequence of smaller, more manageable, and verifiable steps.
Okay, that makes sense. This dramatically improves accuracy on tasks that require multi-step reasoning. Think complex coding logic, mathematical word problems, maybe analyzing cause and effect in a business scenario. It pushes the model away from just making quick, superficial pattern matches towards something more like deliberate, step-by-step thinking.
Yeah, I've seen some benchmarks showing significant accuracy boosts on logic puzzles just by adding a simple phrase like, let's think step by step.
Exactly. And that's the key takeaway for implementation. You don't need some fancy API call.
Yeah.
Often just adding simple phrases like think step by step or explain your reasoning at each stage or show your work is enough to trigger this more robust reasoning process.
But there's a catch, right? It's not free.
Definitely not free. Forcing the model to generate all that intermediate reasoning significantly increases the number of tokens it produces.
Which means?
Two things. Higher latency. It takes longer to get the response, and higher cost, since most models charge based on token usage, both input and output.
So you need to be strategic about when you use COT. It's not for simple tasks.
Precisely. You wouldn't use chain of thought to, say, reformat a paragraph. You use it when the stakes are high, and accuracy on a complex reasoning task is paramount. Maybe verifying the dependency chain for a critical software deployment, or analyzing a complex legal clause.
And there's another benefit too, isn't there? Verification.
Huge benefit. By seeing the reasoning steps, you can verify the logic. If the final answer happens to be right, but the steps show flawed reasoning, you've caught a potential hallucination that just got lucky. It builds trust.
Right. And just quickly, this Katat idea is evolving too, isn't it? Things like tree of thought.
Yeah, that's the cutting edge. Tree of thought, or TOTA-T, basically has the model explore multiple possible reasoning paths in parallel, evaluating them, and then choosing the most promising one. It's even more computationally intensive, but potentially much better for really complex, open-ended problems. Definitely something to watch.
Okay, building on that idea of verifying the reasoning, let's talk about technique 7, requiring justification.
Yes, this is about demanding the evidence. The principle is simple. Require the model to back up its claims, its advice, its data points with specific sources or logical justifications.
So if chain of thought is about the how did you reach the conclusion, then justification is about the what evidence supports that conclusion.
Exactly. It acts as an immediate check against making things up. When you force the model to cite its sources, even if the source is just the specific section of the context document you provided, it pushes the model to double-check its own internal consistency.
Makes it harder to hallucinate if it knows it has to show proof.
Pretty much. This is absolutely crucial for things like research assistants or writing reports that need to be factually sound, or any situation where correctness is non-negotiable.
I can see this being incredibly valuable in fields like finance, legal, or anything involving compliance or regulatory reporting.
Definitely. Imagine a financial analyst prompting. Analyze the potential impact of the latest interest rate decision on the tech sector stock valuations. For every specific prediction or statement about market movement, cite the specific economic indicator, historical precedent, or a quote from the official announcement that supports your claim.
That transforms the output from just generic prediction into a piece of rigorously supported analysis.
It does. And importantly, it shifts the user's role. By reviewing the justifications the AI provides, you, the user, can more easily verify the information and build confidence in it. You're not fact-checking from absolute zero, you're assessing the evidence presented. The burden of proof is shifted more onto the AI.
Okay, the last technique in this section. The engineering part of prompt engineering implies it's not just a one-shot deal, right? It's a process. Technique 8, iterative refinement.
Yes, this is fundamental. You have to treat prompt engineering like an engineering discipline, or maybe like debugging code. It's iterative.
So you don't expect the first prompt to be perfect?
Rarely, especially for complex tasks. The principle is, start with a reasonable baseline prompt. Run it, carefully analyze the output against your desired criteria, and then this is the key part, revise the prompt based on specific targeted feedback.
So it's like having a conversation with the AI over multiple turns, but you're refining the instructions each time, not just the topic. Almost like you're training it on your specific needs and preferences.
That's a good way to think about it. This cycle of trial, error, analysis, and refinement is how you really learn the nuances of how phrasing impacts the results for the specific model you're using and the specific task you're doing.
And the feedback needs to be concrete, right? Not just try again or make it better.
Absolutely critical. Vague feedback leads to vague improvement. If the output was, say, too technical for your intended audience, your feedback shouldn't be make it simpler. It should be something like, your previous explanation used terms like asynchronous processing and API gateway. Please revise it to explain the concept using an analogy suitable for a non-technical marketing team, perhaps comparing it to a restaurant kitchen.
That specificity helps the model understand exactly what needs to change. And this feedback loop helps you zero in on the optimal prompt much faster.
It does, and for our IT audience, this iterative process strongly suggests something else, the importance of prompt version control.
Ah, like keeping track of your prompts like you do with code.
Exactly. If you spend time carefully refining a complex multi-part prompt that works perfectly for generating, say, your quarterly security assessment summary,
You don't want to lose that.
you need to save that exact prompt structure. Treating your best prompts like valuable code artifacts, versioning them, adding comments, explaining their intent, maybe storing them in a shared team library is a crucial best practice for professional workflows. It ensures repeatability, consistency, and allows others to leverage what works.
Okay, we've got a good handle on the core techniques now. Let's zoom out a bit and talk about how these combine to manage more complex, real-world professional workflows.
Right, because rarely is a professional task accomplished with just one single prompt, especially the really complex stuff. Hashtag, tag 5.1, managing complex tasks. Things like, writing a comprehensive research paper, or synthesizing findings from dozens of different data sources, or drafting a full architectural review for a new system. These are usually too big for one prompt.
Especially with token limits still being a factor.
Exactly. You'd exceed context windows or just overload the model. So you have to break these large tasks down.
Which brings us to the idea of prompt chaining.
Precisely. Prompt chaining is the strategy of decomposing that massive task into a sequence of smaller, more focused prompts, where the output of one prompt potentially becomes the input or context for the next.
Can you give an example, maybe for a legal document review?
Sure. Let's say you need to analyze several contracts for potential conflicts. You could chain it. Prompt 1. Go through documents A, B, and C, provided below. Extract only the clauses related to intellectual property rights and indemnification. Format them as a numbered list.
Okay, so that's just extraction.
Right. Then prompt 2, using the output of prompt 1 as context. Review the extracted clauses from prompt 1. Compare and contrast the IP and indemnification terms across the 3 contracts. Identify any direct conflicts or significant inconsistencies.
Now analysis.
And finally, prompt 3, using prompt 2's output. Based on the identified conflicts, draft a short memo summarizing the key discrepancies and proposing standardized language options that would resolve these issues.
So you break it down: extract, analyze, synthesize, or recommend. And the big advantage is token efficiency, right? Prompt 2 only needs the extracted clauses, not the full original contracts.
Exactly. Much more efficient use of the context window. But there's another, perhaps even more critical advantage.
Which is?
Human oversight. Prompt chaining naturally creates points for human review. You can check the output of prompt 1, the extracted clauses, to make sure it's accurate before you let the AI spend time and tokens analyzing potentially incorrect data in prompt 2. It builds in quality control steps.
That makes a lot of sense. And this idea of sequential stateful processing leads directly into the more advanced concept of agentic AI systems, doesn't it? Systems that manage entire workflows using multiple turns.
Yes, exactly. Agentic systems often use structured multi-turn prompts to mimic how a human knowledge worker might tackle a project. They plan, execute steps, perhaps validate the output of each step, maybe even reflect or self-correct before moving to the next phase.
Like an AI assistant managing a small project on its own.
Sort of. For instance, you could structure a workflow for database migration. Prompt 1. Based on this scope document, generate a detailed plan listing all required database schema changes and data migrations. Prompt 2. Using the plan from prompt 1, write the necessary SQL scripts for the schema changes. Prompt 3. Generate unit tests in Python to verify the schema changes implemented by the scripts from prompt 2. The system manages the state and dependencies between these steps. Hashtag tagged 5.2 model-specific optimization. Know your tool.
Okay, so we've established these techniques. Chaining, context, SHU-T are generally applicable. But you mentioned earlier that how you apply them might need to change depending on the specific AI model you're using. We can't just treat Claude and ChatGPT and Gemini as identical, right?
That's a crucial point for anyone aiming for top performance. While the core principles are universal, the optimal implementation often needs tailoring. Different models have different strengths and weaknesses baked into their architecture and training data.
So you really need to test.
You absolutely must test. I often recommend what I call the BIV loop. Baseline your performance with a simple prompt on your target models. Iteratively improve the prompt using the techniques we've discussed, and then verify the results across the different platforms to see which model responds best to that specific optimized prompt structure for that specific task.
Okay, let's do a quick rundown of those comparative strengths, specifically for typical IT tasks. If I need something with really rigid, predictable structure like generating JSON or maybe scaffolding out code files.
For tasks demanding high fidelity to a predefined structure or schema, ChatGPT models, especially GPT-4 and its successors, often excel.
Why is that?
Their training seems heavily optimized for instruction following and adhering strictly to formats like tables, JSON, XML, or code templates. Your prompt style for GPT should lean into providing very explicit schemas and potentially good few-shot examples if the structure is complex.
Okay. What about tasks involving deeper reasoning, maybe summarizing or analyzing really long documents, like hefty technical specifications or research papers?
There, models like Anthropic's Claude often shine. They typically boast very large context windows and are known for strong performance in structured analysis, critical thinking, and maintaining coherence over long stretches of text.
So for Claude, the prompt style should be different.
Yes, for Claude, you'd want to provide rich, comprehensive context, probably make good use of chain-of-thought prompting to guide its reasoning, and maybe even explicitly ask it for critical perspectives like identifying assumptions, potential risks, or mitigation strategies related to the input.
Got it. And finally, what about tasks focused on research synthesis? Pulling information from various sources, needing citations, maybe even involving images or other data types.
That's often a strong suit for Google's Gemini models. They're typically well integrated with search capabilities and are designed for synthesizing information, providing citations, and handling multimodal inputs like analyzing an image of a whiteboard diagram alongside the textual meeting notes.
So for Gemini, prompts need to explicitly ask for sources or verification.
Yes, to leverage its strengths, you'd want to structure your prompt to request citations, specify how you want sources handled, and clearly define parameters if you're using multimodal inputs.
The big takeaway then is know your tools. Don't just use the default. Understand the strengths and weaknesses and tailor your prompt engineering approach accordingly.
Exactly. Don't treat them like interchangeable black boxes if you want the best results. Optimize for the specific model's sweet spot. Hashtag tag 5.3 workflow best practices for professionals.
Beyond the specific techniques and model choices, are there any overarching best practices for integrating prompt engineering successfully into a day-to-day professional workflow?
Yes, definitely. A few key things come to mind.
Let's start with one that often bites people unexpectedly: token awareness.
Oh, absolutely crucial. Tokens aren't free. They directly translate to cost and latency, especially when you're dealing with large inputs, like feeding in a massive log file or a 100-page contract.
You can't just dump the whole thing in the prompt every time.
Not efficiently, no. You need to be mindful of the token limits of your model and optimize for efficiency. If you only need analysis on Chapter 5 of that contract, don't paste the whole thing. Maybe use delimiters effectively so the model can quickly find the relevant section, or use prompt chaining so later steps only need summaries, not the full original text. Smart use of the prompt space saves money and gets you answers faster.
Good point. Okay, what's next? You mentioned something about a safety net earlier.
Right. My second best practice is give the model an out. This is a really important risk mitigation technique, particularly if you're using AI in any kind of automated or production system. You need to provide clear, alternative instructions for the model to follow if it cannot confidently fulfill your primary request based on the provided context.
So it doesn't just make something up.
Exactly. For example, you might add to your prompt, analyze the provided Q3 sales data for regional trends. If the specific metric for the Northwest region is not explicitly present in the data, you must respond only with the exact phrase, data not available, consult manual source. Do not estimate or infer the value.
That directly prevents it from hallucinating a plausible but incorrect number, protecting the integrity of whatever system uses that output.
Precisely. It's about building in guardrails against unreliable answers.
Makes sense. And finally,
and this is maybe the toughest one because it requires ongoing effort, stay updated.
because the field is moving so fast.
Incredibly fast. AI models are updated constantly. New prompting techniques emerge. Best practices evolve. What worked optimally 6 months ago might be less efficient now, or might even trigger unexpected behaviors in a newer model version.
So you need to keep learning.
You do. Following AI news, reading research updates, experimenting with new model releases, it's necessary to ensure you're always using the most effective, most reliable, and most cost-efficient prompting strategies.
Okay, we have covered a lot of ground here. 8 core techniques, workflow strategies, model considerations. If we had to boil it all down, what are the absolute pillars of successful prompt engineering?
I'd say it comes down to 4 main things. Specificity be crystal clear, context ground the AI in facts, role-playing guide its perspective and style, and iteration constantly refine your approach. Those are the levers you really pull.
And the big message for everyone listening, especially in IT:
I hope the big message is that prompt engineering isn't just some niche trick. It's actually a foundational skill now. It's what transforms these amazing but general AI models from just being interesting utilities into truly powerful, specialized assets that are tailored exactly to your team, your company's specific needs and workflows.
It democratizes access to high-quality AI
It
results.
really does.
So what does this all mean?
It means that getting top-tier, reliable output from AI is genuinely accessible. Every software developer, every analyst, every project manager can achieve this, regardless of whether they have a deep background in machine learning theory. It's a practical communication skill you can learn and master.
All right, and as we wrap up, our final provocative thought for you, the listener, to take away and maybe mull over.
Let's hear it.
Think about the most complex, multi-step task you've dealt with recently at work. Maybe it was debugging a really nasty issue or planning out a tricky project phase. Now imagine redoing that task but using AI as a partner. How could you immediately apply chain of thought prompting?
Ooh, good one.
Try asking the AI tool, before you give me the solution, list the logical steps, the prerequisites, and the reasoning you'd follow to arrive at the plan book strategy. Just forcing that explicit reasoning up front, I bet you'll find the whole process becomes significantly clearer, more transparent, and probably less error-prone.
That's a fantastic, practical way to start applying COT immediately. Great first step towards mastery.
Well, thank you so much for joining us for this deep dive into prompt engineering essentials right here on the Data Zen AI podcast. We genuinely hope this gives you some concrete strategies to get more focused, more reliable, and more useful results from your AI tools starting today.
Yeah, absolutely. And if you found this discussion helpful, if it sparked some ideas for your work, please do subscribe to the Data Zen AI podcast on Spotify, Apple Podcasts, or wherever you get your podcasts. Your support means a lot.
It really does. And please send us your feedback or suggest topics you'd like us to cover. Listener input is incredibly valuable to us and the whole Data Zen community. We want to tackle the AI subjects that matter most to you.
Definitely. We build this for the community.
And don't forget to check out datazen.top. We've got more resources. There are articles that go deeper, info on meetups, recordings of past talks, interviews. Lots to explore.
Keep learning. Keep experimenting.
Until next time, keep prompting smart.